Hopefully you've had a moment to try out this problem and predict the products. I'm now going to walk through the solution. And let's start with our very first one. So I have CH3NH2. Now, if I'm not sure if this is an acid or base, because I see a lot of hydrogens, you can always draw out the Lewis dot structure. So in this case, we've got, these structural formulas give you a hint that the hydrogens that follow a non-hydrogen atom are bonded to it. So this carbon has 3 hydrogens bonded to it, then a nitrogen, which has 2 hydrogens. Now, while this nitrogen has hydrogens bonded to it, so these could act as an acid, it has a lone pair. And when you have a nitrogen with a lone pair, these are going to typically, and so let's say always for this class, act as a base. So I've got a base. That means my water will act as an acid. So if my water is going to act as an acid, I am going to I'm going to donate a hydrogen atom from my water to that lone pair on my nitrogen. So for my products, my nitrogen is going to gain a hydrogen. So rather than being NH2, it's now NH3. It's also got positive charge associated with it, because before it was neutral, and now it has gained a proton, so it'll have an overall +1 charge. Now what's left from my water? My water is going to lose a hydrogen, so now instead of being OH2, it's just OH. Because it lost that proton and gained an electron it had in that bond, it's going to have a negative charge. So looking at these two, my positively charged amine is going to be my conjugate acid. And my hydroxide is my conjugate base. And this would be a base dissociation reaction, because I started with a base and water. Now let's look at the second one. So I'm looking at HNO3, which I know I just said that hydrogen's bonded to nitrogen. If there's a lone pair on the nitrogen, it'll act as a base. Well, in this case, that hydrogen is actually bonded to an oxygen, which is bonded to a nitrogen. This is a second way that acids are written, which is setting the hydrogen out in front rather than at the back. So it takes a little bit of intuition and getting used to. In this case, the nitric acid is going to, this HNO3 is our acid. And that makes our water a base. So when our acid and base come together, the acid is going to donate the hydrogen. So this hydrogen on my nitric acid is going to come and form a bond with the lone pair on my oxygen. So my acid is going to lose a hydrogen, so I'll write NO3, and gain a -1 charge because it lost that positive charge. This acid becomes a conjugate base. My other product will be the result of what happens when that water molecule forms the bond with hydrogen. So in this case, it's accepting that hydrogen, so it increases the number of hydrogens it has. So instead of being H2O, it's H3O. And so we'll write that with a positive as well, because it was neutral and it gained a proton, which is a positive charge. So overall, it'll be positive. So my water acted as a base, and it became conjugate acid. And this is an acid dissociation reaction. Let's look at the third one. So when I look at this, I don't see water at all. So now we're probably talking about a neutralization reaction. And if I look, I've got an ionic compound that is a metal hydroxide. So I can think about this as potassium dissolved in water plus hydroxide ion dissolved in water plus my acid, HClO4. Here my hydrogen is again bonded to an oxygen that's then bonded to chlorine. So my acid is the HClO4, my hydroxide is my base. My potassium will be just watching. So my acid will lose a hydrogen to my base. It'll form a bond to the lone pair on the oxygen. This means my base will go from being OH to H2O, or OH2. So I'll gain that hydrogen and go from a -1 charge to a 0 charge. And this is my conjugate acid, because it was formed from my base. Now, my acid loses that hydrogen, so it only has one, so I'll just rewrite the equation without the hydrogen, ClO4, and it'll gain a negative charge. It'll go from neutral to -1. And so that acid forms my conjugate base. And so I ended up with, and that potassium still around as well, aqueous. So together these are a salt, and I formed water. So water and a salt as products, this is a neutralization reaction.